Hello, Screech fans. This is Pauline at the REACH Museum, and this is LiveSTEAM, and this is our very first Planetarium show. I'm going to go ahead and share my screen so you can see what's going on in the night sky tonight. And if you're not able to get out and look at the sky tonight, you'll still be able to see many of these things during the next week or so. What I'm going to show you tonight is all stuff that you'll be able to see even if you're in the city where there's maybe some light pollution. It's great if you can get out to where there's a very dark sky, but if you can't, no worries. You can still see some pretty spectacular things just by stepping right outside your door, turn off the porch light, let your eyes get used to the dark, and start having fun enjoying the sky. We're going to be using an application called Stellarium, and you can find this and download it to use on your computer or your mobile device, but you can also just use it online, and that's what I'm showing you right now. Notice the time is I'll bring this up. This is tonight at about 7:22. So just as it's getting dark enough to be able to see some of the stars. Let's get started. When you go outside, first thing you're probably going to notice if you look to the east is the moon. It's a full moon tonight, and we also call it a blue moon because it's the second full moon in the calendar month of October. This only happens where we get a full moon on Halloween. Only happens about every 19 years, so enjoy the ambiance. You don't need any special equipment to look at the moon as long as it's clear, just your regular eyes. And if you are able to look through binoculars, you're going to be able to see some craters. You're going to be able to see those dark areas that are called maria, and those are cooled lava. They are made of basalt, just like the basalt that's here in Eastern Washington. All right, we're going to zoom back out, and we're going to take a look at a planet that's putting on a really spectacular show. Through this summer and this fall, we've been able to get a really good look at Mars. It's going to mostly appear as a pinpoint of light, kind of like the stars. If you're able to look through binoculars, you'll get more of a sense of it being a disk because it is pretty close to the Earth right now. And earlier this month, it was in opposition, which means that Mars and the Earth and the Sun were kind of all lined up. That means that we're getting a lot of reflection from the Sun off of Mars. Remember, it doesn't make its own light. It just reflects the light of the Sun like the moon does. And it happens to be pretty close. It's going to start getting farther and farther away from us now, so enjoy it now while you can get a close look. And it really is kind of easy to pick out because it's got a nice rusty red color because of all the iron oxide on its surface. You might notice on the screen there's another planet in this direction, Uranus, but it's not one of those that is easy to see. It's pretty distant and you wouldn't be able to see it with the naked eye. You're probably going to need a telescope to pick it out. Okay, so if we bring up the stats, Stellarium tells us that it has a magnitude of 5.66. But what does that mean? Let's compare it to Mars. If I click on Mars and see what that magnitude is, that one says a magnitude of negative 2.14. So why is it that Mars, which has a brighter look to us, it says magnitude is negative 2.14? Well, this is a scale that rates all the different visible objects with their relative brightness from what it appears on Earth. And it just happens that the brighter objects are a negative number, and the lower those numbers get, the brighter the object is. For instance, the moon, which is the brightest thing in the night sky, has a magnitude of negative 12.53. So if you see a positive number for the magnitude, that just means it's not as bright. Also in this direction, we are going to take a look at something that's not a planet, but is an open cluster of stars, the Pleiades. Open cluster means that all of these stars formed from the same cloud or nebula. And so they are relatively the same size. The same age. They kind of formed around the same time, and they are made of mostly the same materials. So that's going to mean that they appear a lot alike in color and maybe even in magnitude. You can usually pick out about 6 or 7 that you can see with the naked eye. But if you were to look through binoculars and take a closer look, and if I zoom in, you're going to see that there are many, many more than just those 7. There are hundreds and hundreds of stars in this open cluster. And they're kind of clustered together because they are still gravitationally related. That doesn't mean that they are orbiting around each other. It just means they're kind of in the same vicinity and sticking a little closer together because of gravity. All right, let's look in a different direction. I'm going to zoom out and turn us towards the south because there are a couple more planets putting on a great show in the south, Jupiter and Saturn. Jupiter is going to be pretty bright and really pretty easy to pick out. Same thing with Saturn, just because it's close to it. And you'll be able to see it without any special tools. However, if you do have a way to look closer, some strong binoculars or a telescope, you can often see some of Jupiter's moons. Now, it's got many, many moons, but the 4 brightest ones showing up here are sometimes called the Galilean moons. And that is because Galileo, when he first made his own telescope, this was one of the first things he started observing. And every night he would look through his telescope, he would point it towards Jupiter, which he was pretty sure wasn't a star, and he was noticing these 4 objects around this object that were changing position every night. So he kept a journal and he made a little sketch of where those 4 objects were in relation to Jupiter and observed how they changed every night. He kept this journal for a period of time and was able to tell that these objects were actually orbiting around Jupiter. Now, how did he know that it wasn't a star? Well, Jupiter and Saturn and Mars, any of the things that are not stars, they're called planets, which the early astronomers came up with that name because it meant wanderers. And that meant that they weren't following the same pattern that the stars did going through the night sky. We'll talk about that pattern a little bit later. But right now, let's take a closer look at Saturn. So the planets, the wanderers, seem to be following their own path and not conforming to the same patterns that the stars were. So that's why they got that name. And later we were able to figure out that they are orbiting around the sun just as the Earth is. So here, a closer look at Saturn. You would need a telescope to be able to see these rings and some of these moons, but many, many moons, but some of the larger ones with names. And a really spectacular thing to see. Let's go ahead and see. The nice thing about Stellarium, too, is it shows you when satellites are passing by, and you can take a look at what those are, too. This one's called Starlink 1292. I went ahead and stopped time, but if you were to start time again, you can see how quickly those satellites are moving through the sky. So watch for these things. They're a lot more distant than airplanes. and they kind of move with a smooth motion, so you can tell that they are satellites. Okay, let's pause time again. And I'm going to zoom out because I want to show you something that is visible in the overhead night sky. And that is, even though summer is way over, you can still get a good view of what we call the summer triangle. 3 pretty bright stars directly overhead: Altair, Vega, and Deneb. These bright stars are part of 3 different constellations. Altair, let's bring up some stats on Altair. Magnitude 0.82, which says it's one of the brightest, the 12th brightest star in the night sky. 16.73 light years away. That means that if we were to try to go to Altair and we had a spacecraft that could travel at the speed of light, it would still take us 16.73 years to get there. That's still pretty far. Vega is a little bit farther, 25 light years. But Deneb is 1,411.95 light years away. So the light that's traveling from that star, when it reaches your eyes as you're looking at it tonight, that's what it looked like 1,411 years ago. You are looking back in time when you look at all of these stars. All right, let's take a look at what the constellations look like. Okay, and imagine, you might know what some of these constellations are, what they represent, but just use your imagination now and look at the shape of Cygnus. What do you think that is? And Lyra and Aquila. And I'll turn on the art in just a moment to show you what some people imagine them to be. As you're thinking about it, though, why is it that this star, that Deneb, is still so bright, even though it's over 1,400 light years away? It's almost as bright as the ones that are much, much closer. And up here it says it's an evolved supergiant star. So the brightness of the stars, the magnitude, doesn't only have to do with how far away it is, but also how big they are. And this one, a supergiant, has got quite a lot of energy. All right, so let's see what our Western ancestors imagined that these shapes represented. Aquila is an eagle. Lyra is a harp or a lyre. And Cygnus, sometimes called the Northern Cross, is a swan flying through the Milky Way. All of these little asterisms, these little shapes that we imagine, will help you remember what some of these stars are, and will help you find your way around in the night sky. Speaking of, you might notice that this thing over here is circled. Let's just click on that and see what it is. North America Nebula. A lot of these things are going to be what we call dark sky objects, and you're probably going to need a telescope to be able to see those. But I would like to show you one thing that's really, really far away that you can see without a telescope. In fact, it's the most distant object that you can see with the naked eye. And in order to find it, we're going to have to find Pegasus. There it is. Let's bring this up here. Oops, sorry, I'm swirling around the night sky. One constellation that's pretty bright and easy to pick out, even in when you're in the city, is Cassiopeia. It's kind of this W shape, and those are some pretty bright stars that you can see kind of towards the northeast. And that can help you find Pegasus, the Great Square of Pegasus, more of a trapezoid really. Okay, and we'll bring up the art for a moment. It's a winged horse, and one of the legs coming off of that winged horse is Andromeda. And this dark sky object that we want to zoom in on is in the constellation Andromeda. And the easiest way to find it is when you find the great square of Pegasus and find this leg coming off of it, you're going to see that this second star has a companion, and the third star has a companion too. Imagine another line that they didn't draw in going out this way. Go to that star and just a little bit farther out. And when you look in this area, if you are in a place where the sky is really dark, you're going to see a blurry, fuzzy gray patch. Okay, that blurry, fuzzy gray patch is actually something pretty exciting. Look through binoculars and you'll be able to see it a little bit better. If you can look through a telescope, you're going to see a galaxy. This is the Andromeda Galaxy. It is the closest galaxy to the Milky Way, and its distance is 2.5 million light years away. Wow, we are really looking far back in time when we see this fuzzy patch in the night sky made up of thousands and thousands of stars. There's so much to see in the night sky. I'm going to leave it at that, but I hope that you get a chance to go out and enjoy at least the moon, some of the planets, maybe recognize some of these constellations. And if you enjoyed this planetarium show, make sure you like us on Facebook or on Instagram and let us know that you liked it. We'll be able to do some more. Thanks for tuning in.